So today we're going to continue off by creating classes in order to create objects easily. We're also going to replace shapes with images. And we're also going to learn how to load a tileset using which we're going to animate the player. So without further ado, let's begin. Alright, so this is where we left off last time. As you can see, we made a simple window where you have a player that you can move around by using WASD keys or the arrow keys. Now, let's close this off and let's continue. Let's start off by creating our object class. I'm going to start defining classes right over here. So we're going to create a object class. And hopefully you'll see why this is important. Essentially, like I said, this is important for making our code more efficient. We could basically create instances of classes without having to have many variables to manage. As you can see, our object class is going to be constructed with 5 variables: the x and the y position, the width and height, and the image that we're going to pass in. So let me just quickly assign all of those to our object. Now let's create a method called draw. So we're going to be calling this instead of our game loop each time in order to display our objects. So let's say def draw self, and then in here I'm gonna write window.bullet, and the first thing that we're gonna pass in is pygame.transform.scale self.image, and we're gonna pass in a tuple which will hold the width and the height of our object. And after that we're gonna write in self.x and self.y for the position where we want to display our image. Now we're not done yet. We're going to create an update method, and I think it would be best if we actually call the draw method in here. And the reason why is because we're already going to be calling this update method in the loop. And another thing that we could do is add a velocity, which, just like the player's velocity, is going to hold a list containing 2 elements, which is going to be 0 and 0 for the x and the y velocity. And inside of our update method, we're just going to add the values of the velocity onto our coordinates, just like so. So we've created our object class in here. Now let's test it out. And in order to test it out, let's first of all create an object list, which is going to be important. And the reason why is because all of the objects that we add are going to go inside this list. We're going to iterate through this list during each frame of our game loop. So let's first of all, inside of our constructor of the object class, write another command called objects.append. And we're going to pass in self. So whenever you create an object, it's just going to add itself to the object list already. Now what we do in here is, for each object, let me just go ahead and iterate through each object right inside here, inside of our game loop, for obj in objects, obj.update. Now if we go inside and play our game, we wouldn't see any changes because we haven't actually created an object. So let's go ahead and create an object. And I'm gonna create a variable called test object. This is probably the place where we want to locate all of our objects. So just make a comment over here saying object. Now let's get back to this and create an object. So we're gonna write object. Then we're gonna pass in the x value and then the y value. I'm gonna give it like 400 and 400. Now for the width, I'm going to give it 50, and for the height, I'm going to give it 50. Now here's the interesting part. What do we do with the image? Well, that is a very good question, because they don't act like shapes. The reason why is because you can't really store shapes, because, well, they don't really need to be stored. But images, we have to actually cache them or load them before we display them on our screen using the bullet method of the window object. So right in here, we have to type out pygame.image.load. Now I have to pass in the file name. And in here I have an assets folder with my images that I can load in. Let me just select a heart image over here, which I'll load into the screen. I'm just gonna write heart.png. But look at what happens when I press play. It will give me an error. Pygame is pretty descriptive and it will tell you that there is no such file as heart.png. But why? You can clearly see it in here. That's because it's located inside of a folder. Be aware of that. So in here, let's type assets/heart.png. Now that should load in our image. Boom, as you can see, we have our little heart-shaped object. Now let's actually get into creating our next class, which is going to be the entity class. And we're going to derive it from our object class, which is going to override the constructor in the object class. So we're going to keep the previous parameters that the object class had, but we're also going to add a tile set in here instead. Now this is important because we're going to be using this on our player, and not just the player, but in the future tutorials we're also going to be adding enemies, so stay tuned for that. I'm just going to fill out these right over here, and I'm going to pass in none in here because we're going to override these methods. Okay, so right over here I'm just calling the constructor from the object class because the entity class derives from the object class. The reason why I added speed in here is because unlike the object class, this entity class is not going to have an image parameter, but it will have a tile set that we'll need to pass in, and it's going to have a speed parameter. Now let's set the speed onto our object, or now it's going to be the entity. Before we set the tile set, let's define another function. Let's call it load tileset, and what it's going to do is it's going to load our tileset. So we're going to need to pass in the file name, a width, and a height per tile. Now if you don't know what a tileset actually is, it's basically like an image that is composed of multiple tiles that we could basically use individually. So essentially one image would contain several images. Those little images would be called tiles. Firstly, we're gonna actually load our image. And now next what we're gonna do is we're gonna define the image width and the image height, and we're gonna get those from the method called getSize, which is inside of our image object. And then we're gonna make a list called tileset. And now we're gonna iterate through our image. We're gonna chop our image into individual pieces, which we're gonna store inside of our tileset. And our tileset is essentially gonna be a two-dimensional list. So for tile X in range 0 to image width divided by the width. Now it's important that we put a double division sign because we want to get a whole number, because range only works with whole numbers. In here we're going to create a line list. This one's going to be a one-dimensional list, and we're going to append this line into our tile set. And right after that we're going to create another for loop. This time we're going to iterate per each column. So here we're just pretty much doing the same thing but with the height instead. Now in here we're going to create a rect object, and a rect object is a tuple which consists of 4 integers. The first one is going to be tile underscore x times width. Then the second element will be tile y times the height. And then we're going to pass in the width and the height. Now we're going to append a subsurface to our line. And we're going to do that by calling a method from our image object called subsurface. And now in here, you would just pass in the rect tuple that we made. And that should be just fine. Now we've basically written a function that will load our tileset. Just don't forget to add a return statement. So we're going to want to return the actual tileset as our very last thing. Now let's go back up and continue where we left off in here. So what we're gonna do is write self.tileset, but instead of assigning our tileset parameter into here, we're gonna call our function load tileset, pass in the tileset, and now you're going to want to pass in the width and the height of each individual tile. If your image consists of tiles that are each 16 by 16, then you would want to pass in 16 by 16. In my case, I have this player sheet, which consists of 9 individual tiles, all in one image. And the width of this image is 48 and the height is 48. Each tile is 16 by 16. So now that we've loaded our tile set, let's try and use it, and let's try and load the first subsurface or the first tile inside of our tile set. In order to do that, let's actually override our draw method. We're going to want to create an image object. We're going to assign it to pygame.transform.scale self.tileset. So in here, we have to pass in 2 indexes. Let's try and pass in 0 and 0. And that should return our first image inside of our tile set, which should be this image right here, the first one. Right after our tile set subsurface, we need to also pass in a width and height instead of a tuple, just like we did instead of our draw method for our object. Now let's draw this image. Window.bullet image self.x and self.y. Now if we try and create our entity object, just for testing purposes again, test entity, and I might just comment this out, but I will copy some of the parameters from the object. Now inside of here, let's pass in the file name of our tile set, which we should set it to be the player sheet png. And let's not forget to add the assets. And the speed value, I'm just going to give it 5 for now. And there you go, we loaded in our player tile. Now I think what we should do is try and assign it to our actual player, which is currently a circle that we're moving around. So we need to eliminate some of the variables that we created earlier, because we will not need them anymore, because we're going to create another class that will derive from the entity class. And because the entity class derives from the object class, it has some variables that we could already use, like the x and the y coordinates that we already use for the player, for example. And other stuff like velocity and speed, which is now in our entity. So let's create another class called player, inherited from the entity class. Let's create another constructor. We don't need to change anything here, but in the future, we're going to add more fields inside of here. Now we can get rid of pretty much all those things except the player input. I'll probably keep the player input as a separate thing for now. So now let's actually create our player object. I'm going to comment this out again. Player object, player equals player class. And let's give it a position that we had earlier, which was the center of the screen. As you can see, what I'm doing to identify the middle of the screen, I'm basically using the window size and I'm dividing the width and the height by 2, which gives me the center of the screen. Now we have to pass in a width and height, 75 for now. Now our tile set is going to be the tile set that we loaded in or tested out earlier. And the speed would be 5 because it was already 5. And we're not done yet because, as you can see, we have some errors. In order to eliminate them, let's say goodbye to our shapes that we drew earlier. This is obsolete, we wouldn't need it anymore because our player is an object and it's gonna be inside of our objects list also. But this right here is important. All we need to do is swap out the underscore to a dot. Alright, so let's just test this out for now. And the player got significantly slow. That's because we're just not using our speed variable. But now let's get into the most interesting part of the tutorial. We're going to be animating our player. And in order to animate our player, we're going to need to make some additions to our entity class. And the reason why I'm going to be doing inside the entity class is because we will need it later for other objects that we might animate, such as the enemies. What I'm going to do is I'm going to create some more variables right beneath our tileset variable. So let's create a direction field and set it to 0. Let's define another variable. I'm going to call it flip x, which is what we're going to use to control the horizontal flipping. Now we're going to get into the frames. So we're going to have a frame counter. Let's just call the variable frame. Now what we're going to do is we're going to call the frames for our walk cycle, called frames 0, 1, 0, 2. So this is going to be a list, basically holding the indexes for the animation sprites. You'll see why this is important, but basically those point to the horizontal indexes. So 0 is our first image, 1 is the second, 0 is back the first one, and the last one is a 2. That would be the last sprite. So let's make a frame timer. The direction variable is going to define which direction our sprite would be looking at. And we're going to have 3 directions: up, down, and horizontal, each one corresponding to the rows that we have in our player sheet. Now let's make another method instead of here. I'm going to call it change direction. It's going to be checking the velocity of our entity, and based on the velocity we're going to change the direction. So we do that by writing if self.velocity, and we're going to point to the x velocity, which is going to be on our 0th index. If it's less than 0, meaning that if it's a negative value, we're going to set the direction to be horizontal. So what I'm going to do is I'm going to create some constants once again. Let me just do that above our frame rate. I'm going to make 3 more constants called horizontal, and I'm also going to make up and down. Now what am I going to set those to? Well, I'm going to point to my player sheet. Down would be equal to 0, and horizontal would be equal to 1, and up would be equal to 2, appropriate. Alright, now let's go back and set the direction to be horizontal. Then, because during the horizontal frame the player is looking to the right, we want to flip our sprite so that it looks like it will be going left. So guess what? We're going to set the flip x variable to true. Next we're going to write elif self.velocity of 0th index above 0. So this is when the player would be going right. And we're going to copy what we wrote in here, and we're going to change one thing, and that's going to be the flip x. We're going to set it to false. Now I'll make another elif statement, and we're going to check our y velocity. So if the velocity will be above 0, we're going to set the direction to be down. Now we're going to make one more final elif statement, and that is for the upwards direction. So we're basically going to be changing or applying changes to our direction and whether or not we need to flip our sprite horizontally if the entity will actually be moving. So there you go. Now, before we draw our image, let's call this method. And then actually, before we draw our image using Blit, let's apply the flipping to our image if we need to. So Pygame has a special method for that inside pygame.transform, which is flip, and you have to pass in image, and let's pass in our boolean, which would be flip x, and we have to pass in another parameter here, which is flip y. So let's just set it to false. Now onto the most important part. We're going to be working with frames right now. So what we're going to do is write if self.velocity of 0th index is equals to 0, and the same for the velocity on the first index is equals to 0. Then we're going to set self.frame be 0, and we're going to write return. So what I'm saying here is if the entity is not moving, then set the frame to 0. At 0 our frame is 0, and the frames would judge which sprite to showcase at which column. And before we actually continue onwards, let's go back to when we initialize our image variable in here in the draw method. What we're gonna do is for the first index, we're gonna pass in a frame, and then we're gonna pass in the self.direction. This right here is the frame, and that judges the position of which sprite we want to choose, and the direction judges from which row we want to choose. And based on those two variables, we're going to pick out some kind of sprite from this sprite sheet. I hope that makes sense. And now let's continue off what we were doing before. Right in here, when I write self.frameTimer plus equals 1. So if our player would be moving, then it wouldn't go to here and it wouldn't just return and stop there. It would continue onward to here where it will bump up the frame timer. And now if it will bump up the frame timer, then we're gonna wait until the frame timer is actually equals to 10 by writing if self.frameTimer is less than 10, then we're gonna return. So since the draw method will be activated or will be called each update frame, then this frame timer would keep on growing until it reaches 10. But if it does indeed reach 10, then we're gonna bump up the frame number. And if our frame number reaches a limit, so because we have 4 frames, we're gonna stop it there. But what I'm gonna write is if self.frame is above or equals the length of our frames, then we're gonna set the frame to 0, basically resetting our animation. And let's not forget and set our timer back to 0. Now, the reason why it's 10, well, there's actually no reason why this is 10. This could be any value. Think of this as the frame rate for the animation. So this could be well enough a frame rate for animations. So let's create another constant called animation frame rate. I'm gonna set it to 10 because I found that to be a pretty nice value, but you could change it to whatever you like. I think now we can try running our game and see if everything turns out to work. If you try and move around, so actually I made a little oopsie. Instead of passing in a frame, we need to actually use our frames list in here. So we're gonna use the frame variable to get a frame from our frames list, and that would essentially decide the column from which we'll be selecting our sprite. Okay, now if we run this, as you can see, our player is moving around. Now there's one more thing that I forgot to do, that is actually assigning the speed. So let's override our update function from the object class. And let's not forget to call the draw method. Okay, now our player is much more faster. Our player is fully animated now, and since we now learn how to load in images, let's load in the background. So I have this background PNG over here, right over here. Let's create a background variable, and we're going to say Pygame.image.load, and let's pass in the file name, which is assets/background.png, and put this inside of Pygame.transform.scale, and let's scale it appropriately to our window size. So I believe we pass in the window size, that should be just fine. In our game loop, instead of filling the screen with white, let's say window.lit background. Perfect, we have our background. Very nice. In the next tutorial, we're going to talk about how to add collisions so that our player doesn't just walk off the map. And we're also going to add projectiles, and we're going to add some enemies. I feel like that'll be a very exciting episode of our tutorial series. So if you're excited for that, be sure to hit a like and subscribe for more. Leave a comment if you found anything frustrating or if you have any questions, comments, or concerns. And I'll see you guys next time. Peace out.